All right, so we're going to have a look at question 1. Question 1a, we obviously need to factorize. It's a quadratic inequality. Oops, pen. So I know I'm going to have x, and it looks like minus plus there would give us a -7. X, it would give us a -8. All right, so we're looking for where that is greater than 0. Of course, that is a happy parabola that crosses at -1 and 8. So where is this graph greater than 0? So this is greater where x is less than -1 and x is greater than 8. Or we could say -infinity to -1 union with 8 infinity. All right, looking at B. So this one's 16 minus x squared, which we know is difference of 2 squares. So I can factorize as so. And this one, we can see it's got a -x squared. So -x squared is an upside down parabola. We know that. And we've got a -4 and a 4 for our roots. So we're saying, where is this graph less than or equal to? So less than or equal to, and we've got the 4's as well. So again, we've got our x is less than or equal to -4. X is greater or equal to 4, and another way of saying that one, minus infinity to -4, union with 4 infinity. All right, and our third one there, we have an x minus 3 squared, and then we have a difference of 2 squares. All right, so we can see here we've got a quartic, and it's a positive quartic. It's an x squared times an x times an x. So it's a positive quartic, and it cuts at 1 and -1, and it bounces at 3. So it's going to bounce at 3, but we also need a 1 and a -1. It is a positive quartic, so we're going bounce at 3, and it goes through 1 and -1. Bad picture, but anyway, we can do it from there. So where is this graph greater or equal to? Greater or equal to would be here, and here all the way along there would be greater or equal to. So we've got x is less than negative or equal to -1, and we've got x is greater or equal to 1. So again, another way of saying that one is we're going minus infinity to -1, including -1, union with, this is a bit, there we go, union with, we're going to go all the way from 1 to infinity. All right, so that is question 1. Let's go to question 2. There is probably a quicker way to do that. Sorry, bear with me. Get rid of that one and that one and that one. All right, so question 2. Solve, again, inequalities, but we've got unknowns on the bottom, so we have to multiply each side by the square of the bottom, because we don't know if it's going to be positive or negative. So I'm multiplying each side by the square of the bottom, and also paying attention to what x cannot be, just in case. So x cannot be, in this case, -2. Okay, then we can keep going. If I put everything on, let's say, this side, if I do it bit by bit, I can actually factorize by x plus 2, and you'll see we've still got an x plus 2 in that first term, and just a -3 in the second term. So we have an x plus 2 here and an x minus 1 there, which is a positive, so happy quadratic. That's at -2, and that roots at 1. And we're saying, where is this graph less than or equal to 0. So under here. Now you can see it would be from -2 to 1, but remember x can't be -2. So we could say it's between -2, but not including -2, all the way to 1, and we will include 1. Oops. So I thought I was... Let's try again. Yeah, okay. All right. Of course, you could have written that also as x is between and equal to 1, and it's between that -2, but it doesn't include that -2. So either way is fine. All right. Let's look at the second one there. So the second one is rather interesting because we've got this x minus 2x plus 2. We've got this difference of 2 squares at the top, and we're multiplying both sides by x minus 2 all squared. So that'll give me another x minus 2 over here, and here it will give me an x minus 2 all squared, remembering that x cannot equal to 2 in this case. Okay, putting that all on one side, and I'm going to factorize at the same time. So they've both got x minus 2 squareds in them. There's an x plus 2 left on this side and a minus 7 left on this side, if I put it all over that side. Alright, so here we've got an x minus 2 squared and an x minus 5. And we're looking for where it is greater or equal to 0. You can see here we're going to get x squared times x, so it's a positive cubic. And I'll just draw it here. 5, and it bounces at 2. So positive, here it goes through there and it bounces at 2. That should be a 5. Alright, so where is this curve greater or equal to 0? So this is the only place where it's greater. Here it would be equal to, but we know we can't have 2 as an equal to. So just x is greater or equal to 5. Another way to say that would be 5. 5, we're including 5 all the way to infinity. Okay? Okay, so question 3. Let's have a look at that. Alright, so these come in handy sometimes, but I should turn them off now, shouldn't I? Okay. So this is an absolute value is greater or equal to 5, and that really means that x minus 3 is going to be less than or equal to minus 5. So it's on the outside, or x minus 3 is greater or equal to 5. So either of those. So let's have a look. That means x is less than or equal to, add 3 and we get minus 2. Add 3 and we get 8. So x is less than or equal to minus 2 and x is greater or equal to 8. Okay, let's look at that second one. If we're solving this absolute value, same thing here, except it's a less than 5, so it's a between. So we've got this is going to be between minus 5 and 5. So we add times 2 both sides. And then we're going to subtract 1 from both sides. And then we're going to divide by 3 both sides. And there you've got your answer. All right. So let's have a look at the next question. All right, I think I can get rid of that page. There we go. Question 4. All right, so here we're given a function and we've got to state the domain and range after it's been moved. And that's pretty easy because you can see here it's been moved across 3 to the right. 3 right, it's gone 4 up. But also don't forget that 2 in front of the function. So really that happened in the second place. So everything was doubled. The y values were doubled. All right, the y values were doubled. So if I take my bottom point here, which is -2, 0, if I take that point and go 3 right, this would end up being, instead of -2, it would be a 1, 0, that would be 3 to the right. If I then doubled the y value would still be 0 times 2, so it would still be 1, 0. If I then went 4 up, it would go up to 1, 4. If I do the same thing with this coordinate here, so here I've got 0, 2, so that point is also going to go 3 to the right, so that becomes 3, 2. It's going to doubling the y value, so it becomes 3, 4, and I'm going 4 up, so that's going to go to 3, 8. All right, now if I do that, you can see it's still, those 2 points are still moving in exactly the same way, so I've still got this quarter of a circle happening. So you can see the x values go from, this one would be 1 all the way up to 3, and the y values go from 4 up to 8. So you can see my domain, if I were to write my domain, would be between 1 and 3. So I could write it 1 and 3. And my range, oops, sorry. So my range is going from 4, including 4, up to 8. There we go. You could say domain is all real x. X is between and equal to 1 and 3, and range would be all real y. Y is between and equal to 4 and 8 as well. Okay, so let's do question 5. Find the Cartesian equation here. So we are given let me get rid of that. We're given x equals 2t minus 1, and if I just rearrange that, so I get x plus 1 over 2 is t. So remember, I need to rearrange it because I need to sub it in to get rid of t. So if I square all that, I get x plus 1 squared on, I'm going to square the bottom 4, minus, is that a minus t, is it? Alrighty. Alright, is that t squared minus t? Then that would be your answer. If you want to make it look nice, you can. You could do all sorts of things to it. So one thing we could do is give it a common denominator. We could expand this out, x squared, 2x plus 1 minus, now we have to double everything here, so we're minusing 2x and we're minusing 2 here. Alright, so when we have a look at that, the 2x's cancel and we've got a 1 minus 2, which is minus 1. So we've got x squared minus 1 all over 4 as our solution. Okay, the B part for that one, you could have all different answers. So probably the easiest one is x is t and y would be t squared, minus 2t plus 1. That would be one set, but you can have anything you like that fits in there. So lots of different answers for that one. Okay, let's go to the next question. So, how do I do that again? Get rid of that one. Let's go to this question 6. If you have a look at this one, let's just make it a touch bigger. The first thing we want to do is draw f of negative x. This is f of x we're given. So remember, our negative x just reflects the graph around the y-axis. So we do need this 3 here. So, oops, pen. So it is now going to go down here. It's going to cross through 3 and 0, and it's got that point there, which is, if I reflect that point, let's put it there. So this is a bit tricky for me to do. This point here, if I reflect that point, is, I think it's about there. So it's going up to there. It cuts through 2 and goes down like that. So there's our reflection over the y-axis. Okay, so that's f of negative x. If I then go to, I could do it. Let's get rid of that one. All right, let's do f of absolute value of x. So the absolute value of x just so instead of kind of reflecting both sides around the y-axis, it just reflects the right-hand side around the y-axis. So I could have kept that drawn, couldn't I? So this point here, which is this point here, and 3. Okay, so it is going to go like this. And we're including, of course, that bit as well. So that will be f of the absolute value of x. Okay, and the reciprocal, so 1 on f of x. So when we do the reciprocal, be a little bit careful. Wherever we have zeros on our original graph, we now have asymptotes. If we've got a 1, for instance, 1 over 1 is still 1. If we've got something like this point here, which is a fraction, you've got, for example, you could actually, we could work that out, but we don't really need to. We just need to know that it goes, actually, I will do it. All right, so it's about, my eyes are no good, but let's say it's 0.75. Negative 0.75, so it's going to, if I divide that, it's going to be negative 1 1/3-ish. So I'm going to put it down here. So just remember when it's less than 1, when I'm doing the reciprocal, it will be more than 1. Of course, this one in the negative direction. So that's our minimum point becomes our maximum point. So if I maybe change color, we know that it's going to go down here and down here because they are asymptotes, and we know this bit is negative, so it must be going like that. Smaller ones closer to, so 1 divided by something close to 0 or very small, it becomes very big. All right, this section, this will be positive there, and this is negative, so it'll go like this. All right, just be careful with your asymptotes. Okay, so that's the reciprocal function. Okay, so if I get rid of that one, the next one is, all right, so this one here for D is y equals plus minus the square root of f of x. All right, so actually I'll just quickly do, if you don't mind, I will quickly do the absolute value one here first because that's nice and easy. So if I do the absolute value, I can't, any of the negative bits become positive bits. So let's see how well I do that. Very badly. Remember that bit is about there. Okay, so alright, so that still stays there and that goes up there. So any negative bits become positive bits. So E is nice and easy. Okay, so the tough one here is the square root function. You want both plus and minus, which is kind of interesting. So what you can do first is think about what domain you're in. So you cannot square root any negative parts. So that makes it pretty easy because there's only one part of our graph there that's positive. So just this part here is what we're going to square root. Now when we square root zeros, we get 0. So we know that those bits are in there. I'll do it with a different color. So we know these bits are in here. When we square root 1, we get 1, so that's there. Square rooting anything less than 1, for example, a quarter would be a half. So, so you get, for instance, where would that be? So say this is a quarter about here. So square root of a quarter becomes a half, so that point goes up there, if you can see that. All right, so sorry, hang on a second. So this is going to look really bad. I want the positive version and the negative version of that. So it's not going to be a circle like it's given you. But yeah, just remember, so for the bits that are, for example, that bit, the height of a quarter, square root of a quarter becomes a half, so that's going to be above the original curve. All right, and I think that is it.